returning him safely to the Earth.
The Eagle has landed. It's one small step for man, one giant leap for mankind. 1201, roger, 1201 alarm.
Time for a great new American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
I believe we can send humans to orbit, Mars, and return them safely to Earth.
Hello and welcome to NASA's Edline News, your weekly update featuring events and activities from NASA Education. I'm Kurt Hogan. I'll be here every week updating you on all of the weekly activities and events offered through NASA Education. Well, the oil spill in the Gulf has the attention of students at NASA Explorer schools nationwide. Many have been showing their concern and asking a lot of questions during the Digital Learning Network's weekly webinars. Take a look at this video. It shows some of the images of the BP oil spill in the Gulf of Mexico. NASA has taken these images from both space as well as from within our atmosphere. Instruments using infrared photography aboard NASA's aircraft called Earth Resources 2 show the movement of oil into Louisiana's wildlife habitats as well as the oil spill movement towards the Florida coast. Researchers aboard this aircraft from NASA's Dryden Flight Research Center in California, as well as aboard the King Air B-200 from NASA Langley, seen right there, are helping oil spill responders with the most massive oil spill cleanup in U.S. history.
Our airborne assets, we have several instruments, but one of the instruments is called the Avarice instrument, and it is able, we are believed, to be able to detect the thickness of the oil, to separate the sheen, which is a very thin film, from where the primary mass of the oil is. And that's important to know because we want to be able to direct the boats and the skimmers to be able to corral that oil.
NASA is also measuring changes in vegetation along the coastline to assess how the oil is affecting marshes, bayous, swamps, and beaches that are difficult to survey from the ground. The combination of satellite and airborne images are also assisting in predicting changes in the ecosystem. Students at NASA Explorer schools have been especially interested in how long the effects will remain after the spill. Well, does teaching about clouds make you feel overcast? Well, if it does, NASA's lifting the cloud of confusion, so to speak, for teachers all over the country. A free online course and workshop held by NASA Educator Resource Centers was offered to teachers nationwide. The webinar is called Clear Skies Ahead, Clearing Up the Confusion About Clouds. Dr. Tina Cartwright of Marshall University covered scientific concepts, and Ted Ensign, West Virginia ERC coordinator, explained really cool ways your students can report cloud observations through NASA's school or GLOBE programs. The course will be available again on the DLN, which stands for the Digital Learning Network, by selecting the DLN Info Channel link. The series will be streamed in Windows Media and Flash. Be sure to check for announcements as to when the webinar will be available again. So you say you want to be a rocket scientist? On June 23rd at the Stennis Space Center in Mississippi, students from around the country are coming for a week-long summer workshop to learn the basic principles of forces and Newton's law of motion through rocketry. Students will also study model rocketry and get a chance to build and launch their own simple rockets. Student teams will be evaluated for hardware integrity and safety before launch day. Launches are free and open to the public for viewing. And finally this summer, NASA's taking the lead and getting young people all across the country excited about STEM education. STEM, of course, stands for Science, Technology, Engineering, and Math Education. It's called Summer of Innovation, and NASA Administrator Charlie Bolden, who just happens to be a veteran of 4 shuttle missions himself, is taking a real hands-on approach.
What's the rocket ship doing? It's orbiting Earth. That's the International Space Station. As long as it goes 17,500 miles an hour, it stays in orbit because the centrifugal force created.
NASA has launched this initiative to use its space and technology programs to boost summer learning, especially for underserved students across the nation. The Summer of Innovation supports President Obama's Educate to Innovate campaign for excellence. NASA will work with thousands of middle school teachers and students during this multi-week program this summer to engage students in stimulating math and science-based education. NASA's goal is to increase the number of future scientists, mathematicians, and engineers using its own vast assets of scientists and engineers.
It's an opportunity to see something that they can only imagine, or sometimes they can't even imagine because they've never been exposed to it. And that's why I think it's absolutely fantastic. We've had a number of schools in which NASA engineers and scientists have gone out into the community and have really turned the school around, have made a dramatic difference in the performance of the students and in the ability of the teachers to teach, because it helps the teachers to become very comfortable with the concepts of math, science, physics, engineering, and that's what it's all about.
Now that is a program all of us here at NASA Education are especially thrilled to be a part of. Thanks so much for joining us today, and be sure to check back often for the very latest in what's happening with NASA Education. For all of us here at Headline News, I'm Kurt Hogan. Stay tuned and make sure you join me following the broadcast for a very exciting and educational event happening right here on this channel. Until next time, we'll see you later.
Will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
Hey, and welcome to the DLN Summer of Innovation webcast series. I'm your host, Kurt Hogan. Each week, we will be featuring a different NASA expert from one of the various NASA centers around the country. And the themes for the web series are Mother Earth, Father Sky, rocketry, life science, the universe, aeronautics, and my favorite, robotics. I'll be back at the end of the event to tell you what's coming up next week, so you make sure you stick around for that. But for now, we're here at the NASA Langley Research Center in Hampton, Virginia, with our very special guest. Her name is Erika Alston. She's an expert in all kinds of scientific things, and we'll get to her in just a second. But during the webcast, you can be sure to, if you have any questions at all, to send your questions right here to nasalearn@gmail.com. So without any further ado, let's go over to NASA Langley in Hampton, Virginia, and that's where we will find my very good friend, DLN coordinator, Ms. Karen Ricks. Karen, how are you?
I'm great, Kurt. Thanks for that introduction. I'm Karen Ricks, the Digital Learning Network Coordinator here at the NASA Langley Research Center, where the Summer of Innovations theme this week is Mother Earth, Father Sky. We talk about the Earth and how it's studied from space and the techniques for how we accomplish those studies. We have with us today Erika Alston. Erika is an atmospheric scientist with the Science Directorate here at the NASA Langley Research Center. And her topic today is aerosols and particulate matter. And again, if you have any questions you'd like to communicate directly to Erika today, you can email those questions to nasalearn@gmail.com, and those questions will be answered during this webcast segment. All right, so Erika, how did you get started in atmospheric science?
Well, I've always had an interest in math and science since when, K through 12, and when I got into college, I decided to major in mathematics, and I found out that I didn't really like the theoretical side. I really wanted to do applied studies, and that kind of led me in the direction of doing applied mathematics and led to my position here at NASA Langley.
Oh, wow, how interesting. So you hear that for all of our viewers out there. You find your interest in STEM, science, technology, engineering, and mathematics. All right, now, so you're saying that you didn't like the theoretical side, or you liked the theoretical side?
I didn't care for the theoretical side. I wanted to work with numbers, and I wanted to apply that type of information to real world problems. And I found the best way to do that was to major in applied mathematics when I completed my graduate degree.
Okay, now, so today you're going to be talking about aerosols and particulate matter.
And
So-
climate change.
And climate change. So okay, what are aerosols?
Aerosols are part of the air that we breathe. We interact with aerosols every day, whether or not we are aware of it or not. Aerosols sometimes can be as large as a few microns, so you can actually see those. And then there's other types of aerosols that are really, really small that you can't see. And then there's the gaseous form of aerosols, where you probably are not going to see that as a gaseous form, but you see the byproduct of those gases.
Okay, well, we're interested in hearing your presentation today. So Erika, take it away.
All right. I want to thank everyone out there for coming and letting us into your office or your building or your facility today and taking a little bit of time out for me to share this information with you. So the topic that I would like to talk to you today is about aerosols and climate change, and I want to give you a brief overview of what these areas are, and more importantly, how NASA uses different techniques, different sensors, as well as different types of expertise to study these problems. So I'm going to start off and tell you a basic outline of what I'm going to be discussing today. So first, I'm going to tell you what aerosols are. I'm going to focus on their gaseous form as well as particulate form. I'm also going to tell you where these types of aerosols can be found, and I'm going to give you some ideas as to how NASA scientists study these types of aerosols. And most importantly, why do you care? Why are these types of things important to you? I'm also going to briefly talk a little bit about the really hot topic, climate change. How will this impact the Earth, and how will it impact you? And I'm going to wrap it up with a summary and a few take-home messages, and then open it up for questions. So, let's begin talking about ozone. You're probably familiar with that term, as you probably recognize it from the hole in Antarctica, as well as smog. Well, that's just the tip of the iceberg with this particular gas. So, ozone has a good portion and a bad portion. Bad ozone is that's trapped very close to the Earth in the tropospheric region of our atmosphere. That's where we live, and that's where the air we breathe resides. Good ozone is in the stratosphere, which is about 15 kilometers above the surface. And the great thing about ozone in the stratosphere is that it protects us from UV radiation that could otherwise harm you, me, and other plant life on the surface of the Earth. So you've probably been driving around, and especially if you live in large metropolitan areas, you've seen signs on the road that talk about code red days or please carpool today, use mass transit. And these are all attempts to try to mitigate some of the poor air quality that ozone can create. You've also probably seen a chart very similar to this when you watch the evening news. They will almost daily, especially in the summertime, provide you with air quality forecasts, and they associate these with specific colors, green being good air quality, yellow, and onto the more problematic air quality, orange and red and above. And on those days, people who are older or younger, who have sensitivities to respiratory problems, should really avoid being outside for long periods of time. So you're very familiar with ozone and what it can do at the ground level. And one way that NASA scientists study this is that we study it from the ground. And we use a series of ground monitors across the continuous United States to measure ozone in real time. And other stations measure ozone over much longer time periods so that we can understand how each state is meeting its compliance. The US EPA regulates different components that can contribute to ozone formation at the surface. So we use these monitors to make sure that the states and different industries are doing what they're supposed to be doing to help mitigate some of these negative effects from ozone.
Erika, so when we're looking at a map like this of the United States and we see all these circles and colors, exactly what does those colors, those circle colors represent?
Well, this is from the US EPA, and this is a 10-year report on the state of air in 2008. So this is actually an 8-year average of ozone concentrations across the United States. The brighter the color, or red, represents higher averages over the 8 years, and the blue or lighter blue colors represent lower concentrations. And what you're going to notice is hot spots occurring, or lighter colors occurring, in large metropolitan areas, such as the northeastern corridor, where you have Boston, Philadelphia, New York, Washington, Baltimore, the Atlanta metropolitan area, Birmingham, as well as Southern California. So how else do we study ozone from the ground? We study ozone from the ground using things that look a lot like weather balloons, except they're called ozosondes. Ozosondes are like weather balloons, except as they rise into the atmosphere, they're taking measurements of actual ozone concentration. And from this information, now this is done globally. So from this information, scientists are able to understand what the pattern of ozone is as associated with height. This provides really great information because scientists need to try to predict where ozone is going to appear for our forecast. And knowing how ozone, or where the high levels of ozone are in the atmosphere, allows these forecasts to be better. Another way we can study ozone from the ground is through handheld ozone meters. And these allow for instantaneous real-time measurements of ozone, which are helpful in areas that experience especially so in areas that experience poor air quality on a regular basis, but also in areas that are more pristine, so you can establish what we call a baseline, or a general understanding of what the great air quality should be, so you can measure that against poor air quality. So NASA's specialty is studying ozone from space. We've been studying ozone from space for over 20 years. We use a variety of different satellites to measure ozone concentrations over Antarctica, and we've been able to determine that the ozone hole, which was discovered in the late 1970s, is in fact slowly repairing itself, which has been really good news. So I told you ozone can affect you in more ways than just poor air quality. One of the ways that ozone can impact life on Earth is through actual degradation or deterioration of plant life. So here in this slide, we have an image of a healthy soybean on your very left. And as we move to the right, we have different levels of ozone damage to the soybean. And what you'll see is that the leaf is turning brown, is losing its ability to create energy because it's losing its chlorophyll. And the more of the plant that is damaged by ozone ultimately will lead to a plant looking like this, where the plant is more than likely going to die. And this is due to ozone's oxidation on the plant surface, basically where it kills off the chlorophyll that helps the plant survive. When plants are damaged by ozone, they can't absorb CO2 from the air. This could have distinct ramifications for us in areas where there are large forests, which is where a lot of carbon dioxide gets used up.
Now, so when we're looking at the picture and we're seeing this discoloration of the plants going from green to like a reddish brown to brown and then dying, can we assume that this has the same effect on humans?
Actually, in a way, totally. What we found is that ozone, surface ozone, can impact people who have respiratory problems. There are increased incidence of children with asthma or allergies having problems during poor air quality days, but also with ozone and with the thinning of ozone in the stratosphere, the good ozone, we have shown increases in the in the number of people who get skin cancer as well as retina damage. So yes, it's not just plants, it's also animals and humans that are affected by increased levels of ozone, whether it be at the surface or less amount of ozone in the stratosphere.
Wow.
Good question. So I have a brief prompt quiz that I'd like to go over with you. Don't worry if you don't know all the answers. I'm not going to keep score. But this will be a great little way to understand, to check your understanding, to make sure you understand what I'm trying to convey to you about ozone. So let's begin. We have a picture of a smokestack. Tell me, do you think that is good ozone or bad ozone? We think this is considered bad. Why do we consider this bad? Ozone is a gas and it combines with different chemicals produced by burning of fossil fuels, such as a coal-fired electric plant, and they create and mix together and form smog. So we consider that to be a bad ozone. Going back to the quiz, we have a gentleman studying soybean seeds. Is this good or bad? We're going to consider that good because healthy soybean seeds can lead to healthy soybeans produce, which ultimately impacts all of us as that provides feed for livestock as well as a food source for humans and other types of animals. So that's definitely a good thing. So now we have a picture of a young boy taking the asthma breathing treatment with the nebulizer. Do you think that's good or bad? We're going to consider that bad. Anytime air quality is above code orange or above, children like him or elderly people should make sure they limit their exposure to poor air quality on those days. Next, we have an image of the hole over Antarctica, the ozone hole over Antarctica. Do we think that's good or bad? This might be a tricky one. Well, the answer is good. And it's good because NASA scientists, along with other scientists from other countries, have identified the hole, and we've been able to make continuous measurements of this ozone hole for almost 30 years. And because we know it, we've identified it, we can now take steps to mitigate it. One of those steps was the signing of the Montreal Protocol, which limit CFC use, or chlorofluorocarbons use in aerosol cans. You've probably noticed if a can of Lysol, you'll notice on the back it says no CFC. This is where that comes from, and this is why it's so important, because we are actually noticing since the passage of that protocol that the ozone hole is starting to heal a little bit. So that's actually a really good thing.
Okay, so the hole over the ozone was the initiator for the no CFCs that we all see on our
Yes.
cans? Okay.
Back in the late 50s to early 70s, in the aerosol cans, one of the chemicals used to propel the gas contained CFCs. And scientists saw this thinning of ozone over Antarctica, and they came to the conclusion that certain chemicals help destroy ozone in the stratosphere. And one of those chemicals were CFCs. It's also led to coolants in refrigerators, air conditioners, whether they be in refrigerators or cars or home units, also are CFC free as well.
Okay, so us recognizing this hole over the ozone, over the Antarctica, is how we now know how to solve a problem, or begin solving a problem.
Solving a problem, and good thing we're seeing results because it shows that small steps can lead to really big actions.
Oh, excellent, excellent.
And I have one more thing on the quiz to ask you. And the final picture is a gentleman wearing sunglasses. Is this good or is it bad? This is great because while we do have good ozone in the stratosphere to protect us from UV radiation, it doesn't protect us from all UV radiation. So it's very important when you spend any time outside, you protect your eyes. We know that UV radiation can cause damage to your eyes or damage to your retinas. So it's really important that you take steps to protect those. All right, so now I've spent time telling you about ozone, and I want to switch focus and focus on particulates. So, you're probably asking yourself, what are particulates? I haven't heard of that before. Well, particulates can be things as large as pollen that you see, or it can be really small particles like things from a fire that you can't see. So to get an idea as to what size particles we're talking about, large particulates, large particles, or what we call coarse, are about 1/5 of the width of one of your hairs on your head. That's small. And they can get larger than that. We have a thing called fine particulate matter, and that actually is 1/5 of the 1/5 of the coarse PM. So you're talking about something that's about 1/9 of the width of your hair. So these are very tiny particles. And the size of these particles are important to keep in mind because that tells you why they're so important to people. So here in this image, I showed two different types of coarse particulates, or large particles. We show volcanic ash, and we also show a dust storm. These are called coarse particulates, and you can really kind of see individual particles or see them clustered together. And with that size, they really can irritate your nose, your eyes, your upper throat. You will cough, maybe even sneeze when exposed to large amounts of these particles. Then you have small particulates, or fine mode particulates. And these are aerosols that can cause haze or smog. And there are also particles that are released during wildfires. And these particles, because they're so small, can actually work their way down into your lungs and actually affect the air-blood exchange that occurs deep within your lungs. This is why particulate matter pollution is a major issue for people who have allergies or asthma. So I kind of said a little earlier why particulates are important to you, but if you have allergies, every spring you see the pollen on the cars, you can't escape it. You also, people who have respiratory problems, who maybe have emphysema or chronic bronchitis, definitely have problems when exposed to high levels of these particulates, whether they're fine or coarse. Additionally, airplanes can't fly when you have volcanic ash or heavy dust storms. We experienced this firsthand during the Icelandic volcano's eruption earlier in May, where it shut down global air transport and people were stranded in airports. And it's simply because the airplanes cannot fly in those types of conditions. So how do scientists study particulate matter? We study it from ground using a network of ground-based monitors. It's kind of similar to what we did for ozone, except these are measuring concentrations of fine particulates. And the higher amounts of monitors are located in areas with the highest population density, and those are going to be in your cities. And you'll notice that a lot of these monitors on this map are located on the eastern seaboard, and then you also have a high concentration in Southern California. Now, the great thing about studying particulates from space is that we can see them. There's a satellite sensor called MODIS that can take pictures kind of like your camera, and it does it for almost 400 miles above the surface of the Earth. So here we have an image of the Icelandic volcano during this eruption. You see the volcano's kind of in the upper part of your screen, and that long brown stream of ash. We picked that up using MODIS. There's another satellite sensor called MISR, and MISR can take images similar to what I showed you with MODIS, but the nice thing about MISR is that it can also estimate what type of aerosol it was, whether it was ash, maybe it was smoke, or maybe it was finer mode particulates, but it also can kind of give you a good estimate of the height of those aerosols in the atmosphere. So when we're looking at this image where it shows aerosol plumes from the volcano, it's important to know how high up in the atmosphere these plumes are, because that determines whether or not planes can fly. And it also determines if there can be aerosol transport, or where aerosols move from one location to another. And we see in the image on the right that those really pretty red and oranges mean that those aerosols are located almost 3 kilometers above the surface of the Earth. So any planes that are able to fly and are above that shouldn't be affected by that plume on that particular day.
Okay, Erika, are you saying that satellites can pick up both coarse and fine particulate matter?
Satellites that measure in the visible light spectrum, or basically satellites are able to take measurements in the same spectrum that we see in, yes, they can actually make a determination. Well, they can actually, you see it visually, so then humans can make the determination as to what type of aerosol it is, if it's a haze event, if it's smoke, if it's volcanic ash. That's actually a human thing. The satellites can take the picture, but it actually involves human interpretation.
Okay.
So another satellite sensor that we use to study these types of events is CALIPSO. And I think CALIPSO is really cool because it's almost like an X-ray in space. What it's able to do is it's able to see through the atmosphere and provide you with a three-dimensional image of the aerosols and clouds that it encounters. What it is actually a laser in space, kind of like a pinpointer, except it stares down through all the layers of the atmosphere and it gives information on where in the atmosphere they're located. Are they in the stratosphere or in the troposphere where we live? In this image, we're showing volcanic ash. And what you'll notice in the red box is that it's a large area covered by this volcanic plume of ash, but also you'll notice that it's located kind of higher up. It's located anywhere from 6 to 8 kilometers. So this is at the very top, very close to the top of our troposphere. So people at the surface on that day are not as likely to be impacted by those volcanic ash aerosols on that day. However, it could impact air flight because of the location in the atmosphere. So I wanted to briefly tell you a little bit about what an average day in my shoes is like. So what my interests are is I'm interested mostly in particulate matter and how they respond to and what happens in cases of biomass burning or wildfires, and what was going to happen to these particulate matter events in the case of climate change. And I want to understand how that'll impact air quality, as well as understand how that's going to impact large populations of people, as well as different types of ecosystems. So on a day, I look a lot of times at images from the satellites that I've shown you. I also do a lot of analysis with line graphs, bar graphs, all different types of graphs. So if you're in school and you're wondering, am I ever going to use this type of math, you will. And it's actually valuable. People spend years, decades even, doing basic things to convey very tough topics, but do it in a way so everyone can understand. And that's a good portion of what I do as well, is I take information that maybe everyone doesn't understand, and I try to make it into smaller pieces so that everybody can understand why is it cool, and more importantly, why is it important. So I want to give you a quick check your knowledge or pop quiz again with particulate matter. I'm going to show you different images, and I want you to tell me if you think those are small particulates or large particulates. All right, let's start. We have an image of pollen. Do you think that is large, or do you think that's small? Well, they're large. They're large particulates. Why? Because these are things you can actually see. Pollen can be almost 10 microns, and to give you an idea of what that is, that's about, let's say that could be about half the width of your hair. All right, the next image is volcanic ash. Do you think those are large particulates, or are they small? Those are large particulates. Again, what you're seeing here is maybe not the individual pieces of ash, but what you are seeing is those pieces of ash clumping together and forming large clouds, or even pumice, which is hardened ash. So here we have an image of haze over LA. Do you think that is small particulate or large particulate? These are small particulates. And they're small because you can't see the individual particles, so you have to see them as a collective group. In a day like this, I would suspect that people who have asthma, young children, or elderly people probably should be limiting their exposure on those days where it looks like that. And finally, we have an image of a dust storm. Do you think those are small particulates, or are they large? They are considered to be large particulates. When you look at dust, you can actually see individual grains of sand. Taken collectively, they can form dust storms, which are definitely problematic, especially in areas near deserts in the U.S. Southeast and off the coast of Africa due to the Sahara, as well as in Asia, where you have the Gobi Desert. So people who live close to these regions probably experience dust storms on a regular basis and have to walk around wearing protective face gear. So now I'm going to switch focus one more time from particulates and I'm going to focus now on climate change. Now, I know people have heard that buzzword quite often, and you're probably wondering, what exactly does it mean? Does it mean the polar bears are going to die? Does it mean that, the earth is going to warm and there's nothing we can do about it? I want to spend a few minutes showing you what I believe is evidence for climate change, a warming world, and I also want to show you how NASA is studying that and maybe give you ideas of what we can do to help mitigate it. All right, here we have an image of a glacier in Alaska taken in 1906. You notice in the background you'll see a mountain range. In front of that, the large white area is actually a glacier. And in front is actually a moraine, which is basically a large pool of dirt. Now let's see what's happened to that glacier about 100 years later. In 2004, here's that same image, and you see no glacier. This is what we call glacial retreat, and that's when the glacier, instead of expanding or moving forward, actually retreats further back. It is melted away. So we see in this image, almost 100 years later, that the glacier is so far receded, we can't see it. What could cause that? Warming. And the result is no different than if you had a nice cold glass of iced tea. If you let your ice sit there long enough, the ice will melt, form condensation on the outside of the glass, and eventually melt into the rest of your drink. So where do we think the warming temperatures are coming from? We believe that it's caused by carbon dioxide. Carbon dioxide is a byproduct of fossil fuel consumption. And that's what we use when we drive our cars. It's what we use to create most of the electricity in this country. Most anything we do involves fossil fuels. Fossil fuels release CO2. So scientists have looked at the amount of carbon dioxide for the last 130 years. And we've seen an increasing trend in carbon dioxide. Interestingly enough, we've also seen a matching trend in surface temperature levels. And this is the reason why scientists believe that the warming trend that we're detecting is most likely caused by carbon dioxide, and that it's actually caused by man-made actions or anthropogenic causes. Because around this time, in the late 19th century, we were starting the Industrial Revolution, where all types of machines started, instead of using humans as their power source, so we started using artificial power sources such as coal, oil, or gas. Now, I also want to talk to you a little bit about sea ice, a little similar to glaciers, but what we're seeing over the North Pole is the amount of ice that forms every year. We've been noticing that that amount of ice is dropping every summer. Every summer, that's when there's the least amount of ice, and this is what I'm specifically talking about. We've noticed since we started looking at it about late 1970s that sea ice minimums have been decreasing. In fact, 2007 was the lowest year on record. And this is done not only through satellite data, but it's also done through ground-based measurements where people trek up to the North Pole and actually make measurements of the ice thickness. So if you have you have glaciers melting, you also have polar ice caps melting. Where does the water go? It goes in the oceans. And just like if you're in a tub of water, you're taking your nightly bath, you sit in the tub and you sit into the water. What does the water do? It goes up. We're experiencing the same thing along all the coastlines of the world, where you have increased amounts of water leading into the oceans. That's leading to subsequent sea level rise in coastal areas or islands, or any other areas that might be low-lying. So here I have an image from the University of Arizona, where they've run very big models based off of real data input from satellites and ground-based measurements, and they use very powerful computers and the computers predict what they think will happen using the data that's been input into them. So we're looking at southern Florida. With only 1 meter of sea level rise, and 1 meter is about 3 feet, okay? 1 meter of sea level rise could subsequently lead to almost all of southern Florida being erased. All the Florida Keys will be covered by water. 3 meters sea level rise, so we're talking roughly 9 feet. Or you could say maybe a building that's maybe a story and a half tall will cover most of southern Florida, including Jacksonville, and as well as some areas on the Florida Panhandle. These are all issues that coastal parts of Florida are going to have to take into account in the future. Here we have Louisiana, and I'm sure you're familiar with this state because Katrina in 2005, Rita in 2006, as well as the recent BP oil spill occurring right now. So what will happen to this part of the world if we have sea level rise? Well, we see whether it's 1 or 3 meters of sea level rise, large areas of southern Louisiana will be lost, will be covered by water, including the greater New Orleans metropolitan area. And finally, I want to show you what's going to happen to the Northeast Corridor, where a large majority of the cities in the United States are located, from Boston to Philadelphia, New York, to Rhode Island, Delaware, as well as the Baltimore, Washington area. You'll notice that under 1 meter sea level rise, 3 feet, that areas such as our nation's capital, Norfolk, Virginia, the North Carolina Outer Banks, and even New York City are at risk for being covered with water. Under a 3 meter rise scenario, we see that now Philadelphia, Delaware is in trouble, Baltimore itself is in trouble. That area in Virginia has extended inland, possibly affecting things all the way up into Yorktown, into the Yorktown-Williamsburg area, which is fairly far inland. So any areas that are close to sea level, if these models and predictions are right, these areas, these coastal areas, are really going to have to take into account what this possible sea level rise could have on their environments. Some places such as Venice in Italy have actually gone so far as to take very proactive steps by installing a seawall to help mitigate the rising seas in the city that's already below sea level. So here at NASA Langley, we study climate change as well, and one of the instruments that we use to study that is the CERES instrument. And CERES is a very interesting instrument in that it can take pictures, not like camera pictures, but they take pictures of the energy that's coming from the sun, and then they take pictures of what the Earth is putting back out. As you know, if you go outside and stand for a little while, you'll heat up, and that's because the sun has given you energy, and you are putting off that energy in the form of heat. So that's what CERES measures. It actually measures the heat the Earth puts back out, and it measures how much energy the sun puts in. And that really is climate change in a nutshell: how much comes in from the sun, how much goes out from the Earth. When these two things are in balance, everything's great. But in an event where the Earth is putting out less than is coming in, is warming the Earth. We know this because I'm sure you've heard of the greenhouse effect, where we have carbon dioxide and other carbon-based gases that trap heat in the interior of the Earth to keep us warmer than it would be than just by the sun. Well, the problem is if we continue to increase the amount of these carbon gases, it's going to trap more heat. So the Earth is going to put out less heat, and that balance is off scales. And that's what we think is happening to us right now. But you're probably wondering, is there anything that I can do? And there are things that you can do to make a small change that will lead to bigger impacts. Carpool if you're able to do so. Ride bikes instead of cars. Or take mass transit if you're able. Install energy efficient appliances and windows in your homes. Installation. There are many steps that we can take. Possibly even grow a small vegetable garden. There are many things that you can do to help mitigate some of these potential pitfalls from climate change. So don't feel like it's a hopeless thing. It's not. You can take personal responsibility and do one small part, and if everyone does a small part, we can really make some big changes. So finally, I'm going to give you a few take-home messages. Good ozone is in the stratosphere, and it helps protect the Earth from UV radiation. Bad ozone is in the troposphere, and it's really close to the surface, and it can damage plants, humans, and other animals. and it can lead to poor air quality through the formation of smog. Particulates are another form of aerosols, and they come from natural sources such as volcanoes and deserts, and they also come from man-made sources such as car exhaust or fossil fuel plant burn. These things create particulates as well. Large amounts of these particulates can lead to poor air quality. And importantly, NASA scientists use a variety of ground-based observations, satellites, and different specialties. There are people who do oceanography, there are people who do ecosystems, there are people who do atmospheric sciences, there are people who study geology, and they use all these different expertise with these different measurements to help understand aerosols and climate change, and more importantly, what their impacts are to you, me, and everyone else. And when you think of climate change, don't feel overwhelmed. It could affect a lot of people, but there are small things that you can do that could lead to really big impacts. And finally, small changes that we can make today will ultimately make tomorrow better.
Well, thanks, Erika, for that enlightening presentation. I want to check with our webcast audience. I think we have a few questions coming in.
Okay, great.
Okay. One of the questions came from Paul out in Atlanta, Georgia. Are aerosols the same as greenhouse gases?
That's a good question. Aerosols are not the same as greenhouse gases. As I mentioned before, aerosols can come in two different forms, or at least two different forms. You have gaseous form and then you have particulate form. Greenhouse gases are actually carbon-based gases such as carbon dioxide, carbon monoxide, methane, and they belong to a family that, as I said before, are carbon-based. And what they do is they help trap some of Earth's heat and keeps it in the Earth, or keeps it within the Earth system and doesn't let it go back out to space. Whereas ozone is specifically a gas that can do, that really impacts more air quality.
Okay. All right, so there is a significant difference between the two. All right, now we have another question. This is from Jenny Leslie in Virginia Beach. Oh, she has a comparison too. Are ozone and smog the same thing?
Ozone, they're kind of intertwined.
Okay.
A lot of times, smog is actually a contraction of a word, smoke and fog.
Okay.
Smog. But a precursor that leads to smog formation is ozone a lot of times. Then you also have haze events, which are usually have more particulate form, but they also can have ozone mixed into it. A lot of times you have naturally emitted gases from, let's say, plants and trees, and then you have anthropogenic sources, car exhaust, smokestack exhaust, and they kind of cook under the sun and they create smog. But you need certain gases and certain things to be there to create it. So ozone is definitely linked with smog formation.
Okay, so there is a definite connection between the ozone and smog. All right, now from Canton, Ohio, how long has ozone been a problem? I think you mentioned that in the presentation. Can you remind our viewers?
Scientists have been studying the ozone hole from space since the early 80s. The ozone hole was actually identified in the mid to late 70s. And that's, as I said, you know, scientists noticed the hole and then they started trying to figure out what caused the hole and then is there anything we can do about the hole. And that ultimately led to a Montreal Protocol.
Okay, so we have to answer that directly. From the late 1980s, we have been aware of this ozone and been trying to find resolution. And we've been a little bit optimistic and successful.
Yes, it's hoped that by 2100, that the whole, given current participation by all the nations with the Montreal Protocol, will actually lead to a complete healing of the ozone hole, hopefully by 2100.
Oh, well, that's...
I know that seems a little far off, but the fact that, you know, small actions taken every day by you not buying a can that has CFCs, to know that it actually can cause the Earth to heal itself is a really powerful testament to the integrity and the strength of our planet.
Oh, well, you know, the good news is it is healing itself. That's good. Okay, let's see. We have Randolph out of Newport News. And he wants to know, why is the ozone in the upper atmosphere considered good, but the ozone near the surface is considered bad?
Even though it's the same gas, it performs totally different functions depending on its placement in the atmosphere. When ozone is located in the stratosphere, it performs a protective layer, and it actually helps protect all life on Earth from UV radiation. When it's in the troposphere, it can no longer protect us from UV radiation, but what it can do is mix with other gases and other particles to form smog and other poor air quality events. So that's why we can say ozone is good up high and bad down low.
Okay, all right, so there's more of a direct effect. Okay, I think we're having a lot of questions here. I think people are concerned about futuristic problems here. One is from Trini. If we continue living this way, how long do we have before plants stop creating enough oxygen to support us?
Ooh, that is a good
Trini,
question.
that's a good question.
That is a really good question. Well, you know, it's a little bit harder for me to answer. I think if we can take steps to prevent large destruction of our forest, I think this won't be a problem. If we can help stop deforestation in large areas where there are forests, such as the Amazon rainforest in Africa and Asia, these are great areas where carbon dioxide is being absorbed and helps these plants grow. And if we can put efforts into decreasing our dependence on trees or other green plants for our needs, I think the Earth always has a way of getting it right.
Okay.
If we could stop doing too much in one area, I think given enough time, it can heal itself, similar to the ozone hole. So I don't think, I'm hoping that there won't come a time that the plants completely shut down and stop absorbing carbon dioxide.
Okay.
I'm hopeful that that won't happen.
Okay, so can we tell Trini that conservation is
Totally,
key?
totally conservation.
Okay.
Total conservation. And keeping, helping with the deforestation also will ultimately help with other areas of our lives. It can also help improve water quality in our oceans. It's all very interconnected.
Okay. Okay, well, Trini, I think you have something optimistic to look forward to there.
Hopefully so.
All right, we have one last question from our webcast audience. And, this is another futuristic question. Is about the impact that particulate matter, in particular, have on our future.
Well, some of the research that I've read, when they run models to predict what could happen in the future, a lot of them say that in a warming climate, it is quite possible that you have more events of poor air quality due to the particulate matter, especially, as well as ozone. Unfortunately, because it's very hard to predict. There are many different things that have to occur to have increases in particulate matter as well as surface ozone. And so scientists are still working to better understand what these mechanisms are so they can make better computer programs to predict these things. So I have much confidence in another, maybe 10 to 15 years, we'll have a much better handle as to what exactly will happen in the future as far as particulate matter and ozone is concerned in a warming climate.
Okay, so Stacy out of Norfolk, that was her question, or his question. So remember, the key word there that Erika said was better computer modules, right?
Yes.
So better models and technology. So for all of our students, technology is key. You're good on the computer,
Certainly.
You're good with technology, you could be our answer to a lot of these problems.
Certainly, and there's a big need for people in the STEM sciences, science, technology, engineering, and math, but also people who have good computer skills, because maybe someone who's good in math maybe isn't so good at computers. So it has to be a collaborative effort between people with different specialties to really answer some of these burning questions that are going to have to be answered in the very near future.
Erika, I do want to thank you again for enlightening us in your presentation on aerosols, particulate matter, and climate change. And thanks again for our audience. Thanks for joining us here at the NASA Langley Research Center. Kurt Hogan, can you tell our audience what they have to look forward to next week?
Next week we'll be coming to you from, like I said, the Kennedy Space Center, and we look forward to seeing you all next time. Thanks so much for joining us. Again, I'm Kurt Hogan, and we'll see you next time. Next time I won't be so tongue-tied. Take care.
Now it is time to take longer strides.
Achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
The Eagle has landed. It's one small step for man, one giant leap for mankind.
great new American enterprise. Time for this nation to take a clearly leading role in space achievement, which in many ways may hold the key to our future on Earth.
I believe we can send humans to orbit, Mars, and return them safely to Earth.
Hello and welcome to NASA's Edline News, your weekly update featuring events and activities from NASA Education. I'm Kurt Hogan. I'll be here every week updating you on all of the weekly activities and events offered through NASA Education. Well, the oil spill in the Gulf has the attention of students at NASA Explorer schools nationwide. Many have been showing their concern and asking a lot of questions during the Digital Learning Network's weekly webinars. Take a look at this video. It shows some of the images of the BP oil spill in the Gulf of Mexico. NASA has taken these images from both space as well as from within our atmosphere. Instruments using infrared photography aboard NASA's aircraft called Earth Resources 2 show the movement of oil into Louisiana's wildlife habitats as well as the oil spill movement towards the Florida coast. Researchers aboard this aircraft from NASA's Dryden Flight Research Center in California, as well as aboard the King Air B-200 from NASA Langley, seen right there, are helping oil spill responders with the most massive oil spill cleanup in U.S. history.
Our airborne assets, we have several instruments, but one of the instruments is called the AVARIS instrument, and it is able, we are believed, to be able to detect the thickness of the oil, to separate the sheen, which is a very thin film, from where the primary mass of the oil is. And that's important to know because we want to be able to direct the boats and the skimmers to be able to corral that oil.
NASA is also measuring changes in vegetation along the coastline to assess how the oil is affecting marshes, bayous, swamps, and beaches that are difficult to survey from the ground. The combination of satellite and airborne images are also assisting in predicting changes in the ecosystem. Students at NASA Explorer schools have been especially interested in how long the effects will remain after the spill. Well, does teaching about clouds make you feel overcast? Well, if it does, NASA's lifting the cloud of confusion, so to speak, for teachers all over the country. A free online course and workshop held by NASA Educator Resource Centers was offered to teachers nationwide. The webinar is called Clear Skies Ahead, Clearing Up the Confusion About Clouds. Dr. Tina Cartwright of Marshall University covered scientific concepts, and Ted Ensign, West Virginia ERC coordinator, explained really cool ways your students can report cloud observations through NASA's school or GLOBE programs. The course will be available again on the DLN, which stands for the Digital Learning Network, by selecting the DLN Info Channel link. The series will be streamed in Windows Media and Flash. Be sure to check for announcements as to when the webinar will be available again. So you say you want to be a rocket scientist? On June 23rd at the Stennis Space Center in Mississippi, students from around the country are coming for a week-long summer workshop to learn the basic principles of forces and Newton's law of motion through rocketry. Students will also study model rocketry and get a chance to build and launch their own simple rockets. Student teams will be evaluated for hardware integrity and safety before launch day. Launches are free and open to the public for viewing. And finally this summer, NASA is taking the lead in getting young people all across the country excited about STEM education. STEM, of course, stands for Science, Technology, Engineering, and Math Education. It's called Summer of Innovation, and NASA Administrator Charlie Bolden, who just happens to be a veteran of 4 shuttle missions himself, is taking a real hands-on approach.
What's the rocket ship doing? It's orbiting Earth. That's the International Space Station. As long as it goes 17,500 miles an hour, it stays in orbit because the centrifugal force created.
NASA has launched this initiative to use its space and technology programs to boost summer learning, especially for underserved students across the nation. The Summer of Innovation supports President Obama's Educate to Innovate campaign for excellence. NASA will work with thousands of middle school teachers and students during this multi-week program this summer to engage students in stimulating math and science-based education. NASA's goal is to increase the number of future scientists, mathematicians, and engineers using its own vast assets of scientists and engineers.
It's an opportunity to see something that they can only imagine, or sometimes they can't even imagine because they've never been exposed to it. And that's why I think it's absolutely fantastic. We've had a number of schools in which NASA engineers and scientists have gone out into the community and have really turned the school around, have made a dramatic difference in the performance of the students and in the ability of the teachers to teach, because it helps the teachers to become very comfortable with the concepts of math, science, physics, engineering, and that's what it's all about.
Now that is a program all of us here at NASA Education are especially thrilled to be a part of. Thanks so much for joining us today, and be sure to check back often for the very latest in what's happening with NASA Education. For all of us here at Edline News, I'm Kurt Hogan. Stay tuned and make sure you join me following the broadcast for a very exciting and educational event happening right here on this channel. Until next time, we'll see you later.
Will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
What we're looking for is not just to continue on the same path, we want to leap into the future.